Hello friends, myself Niyati Chauhan, Assistant Professor at LJ Institute of Engineering and Technology, Department of Instrumentation and Control. Our subject is Environmental Instrumentation. So in this subject, today I start Unit 3, Sedimentation and Flotation. So in this unit, today I discuss Stokes law and settling of discrete particles with equation. So let's start unit 3, sedimentation and flotation. First I discuss Stokes law, right? So sometimes in GTU question can be asked, explain Stokes law in 3 to 4 marks. Okay. Stokes law explains the relationship between settling rate and particle diameter. Okay, so let's discuss. Here you can see in this diagram, this is homogeneous medium. This is homogeneous medium. We can take as a homogeneous medium glycerin, right? Water, okay, etc. We can take as a homogeneous medium. Here particle move inside a fluid, right? And radius of particle is r and velocity is v. Okay, and in this particle there is a viscous force is available in upward direction, right? Viscous force on object depend on following factors, right? Viscous force on object inside a fluid depends on following factors. Number one, shape and size of object. Number two, speed of object. And at last, number three, viscosity of fluid. Okay, here we can say that shape and size of object can be, say, radius r. Speed of object can be, say, velocity, and viscosity of fluid can be, say, eta. So Stokes law give magnitude of force, right? So here we can say Stokes law give magnitude of force, right? So we can say that force on object depend on radius, right, speed of object and viscosity of fluid. Okay, so Stokes law give us magnitude of force, and force depend on radius of object, velocity of object, right, and viscosity of object. Here we put one constant, and constant is equal to 6 pi, right? So 6 pi into r into v into eta. Okay, so from Stokes law we get equation of force, right? And r is radius, okay, v is velocity, and Eta is viscosity of fluid, right? Okay, got it? Discrete particles. Discrete particles that does not alter its shape, size and weight while settling or rising in water is called discrete particles, right? In that means discrete particles, they does not change its shape and size in any medium. Okay. Next question, explain settling velocity of discrete particles with equation. So in this question, I derived equation of settling velocity. Okay. So here one object moving inside a fluid. Okay. So this object has a d diameter. Okay. And on this object, one force is gravitational force, right? Another is drag force, and next is buoyant force. Okay. So on this object, there are three forces available. Okay. So first I derive some basic equations. Here rho F is equal to density of fluid. Okay. And rho S is equal to density of object. Okay. We know that one basic equation, density is equal to mass upon volume. We can say that mass is equal to density into volume. Give equation number 1. Here we have spherical object. So volume of this object is 4 by 3 pi r cube, right? So we know that d is equal to 2r. Okay, so r is equal to d by 2, right? Radius is equal to diameter upon 2. Okay, and here cube. So volume V is equal to 4 by 3 pi d cube upon 8, right? 4 2, right? So we get final equation of volume is 3 into 2 is 6 pi as it is and d cube. So equation of volume is pi by 6 d cube. Give equation number 2. First we find out gravity force, right? Gravity force represented by Fg. Okay. So Fg is equal to mass of object into g, where g is acceleration of gravity, right? We know that mass is equal to volume into density. Okay. So mass is equal to volume into density. Here I am taking density of object, right, into g. So mass of volume is pi by 6 d cube rho s into g, right? Give equation number 3. Okay, equation number 3. Equation number 3. Okay. Next force is buoyant force, right? Buoyant force is upward direction of object. Okay, so buoyant force Fb is equal to mass of fluid into G. So Fb is equal to mass is equal to volume into density, right? So here we are taking density of fluid into volume. So volume is pi by 6 d cube G. Give equation number 4. Okay. Next force is drag force. Drag force denoted by Fd. Okay. So here drag force sometimes known as viscous force. Okay. So we know that equation of viscous force, that is 6 pi eta r v. Okay. Here 6 pi is constant, eta is viscosity of fluid, r is radius of object, and v is velocity of object. Okay. And give equation number 5. Okay. So here we are doing algebraic sum of all forces, right? And you know that all forces on object, okay, one is gravitational force Fg, which is in downward direction, right? Then after another is drag force, and then after another is buoyant force Fb. Here downward force as a positive, right, and upward direction force as a negative, right? So we are doing algebraic sum of all three forces, so we get Fg minus, because downward side force I am taking as a positive, right, and upward direction force taking as a negative. So Fg minus Fb minus Fd is equal to 0, right? So sigma Fy is equal to 0. Algebraic sum of all forces on y-axis is 0. So we know that Fg, that is gravitational force, Fb buoyant force, and Fd is drag force, right? So put out all values in this equation. Then we, so here gravitational force Fg is equal to rho s pi d cube G upon 6, right? Buoyant force Fb is equal to rho f pi d cube G upon 6, and drag force 6 pi r eta into V. So sigma Fy is equal to 0. So put out all values in this equation, right? Then we get rho s pi d cube upon g upon 6 minus rho f pi d cube g upon 6 minus 6 pi r eta v is equal to 0, right? So here rho s minus rho f, right? So pi, same terms written here, pi d cube g upon 6 is equal to 6 pi r eta to v. Okay. So here pi cancel. Okay, pi cancel, right? And we know that rho s minus rho f d cube g upon 6 is equal to 3 into 2r, that is diameter d, eta into v. Okay, 1 d cancel out. So final equation, here we can say velocity, right? So settling velocity of discrete particle v is equal to rho s minus rho f upon 18, right, to eta. Okay, and here 1d cancel out, so d square. So settling velocity v is equal to rho s minus rho f d square g upon 18 into eta. Okay, so this is equation of settling velocity in discrete particles, right? Next, we discuss some MCQs. Okay, sometimes question can be asked, blank is a physical water treatment process using gravity to remove suspended solid from water, right? So which type of process we are using here? First option, settling basin, then flocculation, then sedimentation and compression. So here answer will be sedimentation, because in sedimentation process, right, suspended particles removed from water, right, and all particles collect on bottom side. Next question, in Stokes law, terminal settling velocity equation becomes, first, v is equal to rho s minus rho f g d square 18 into eta. Next, rho s minus rho f g d square upon 9 eta. And last, v is equal to rho s minus rho f g r square 9 eta. So answer will be v is equal to rho s minus rho f g d square upon 18 eta, right? Thank you for listening me. If you have any query, then you can ask me.